Hello. Whoa, that's not a good start, is it? Let's change to a better view. There we go. Yeah. So StreamYard starts in whatever view you had up last, and looks like I was just setting up the desktop and didn't switch it to the solo view. Ah, well, never mind. That's partly what this stuff's all about, is learning how to get back into the muscle memory of pressing all the right buttons. And I keep changing things about the setup. So at some point this will settle down, hopefully through experience of what works in this environment. Anyways, we are here today to do the 11th and 12th, so the final 2 days of the PiHut Maker Advent Calendar, the 12 Days of Codemass project. And been doing this on stream for this week and the previous week, and we've basically caught up in time for today. It's Friday. It's the last working day before Christmas, so I am aiming to wrap this up then and then figure out something else to do with this space in the time between Christmas and New Year. I'll try and do something in that time rather than just say, you know what, we'll start on New Year. Starting in January might be a bit rough because my January starts with a root canal on January the 2nd. So probably won't be streaming that day, but I don't know. Keep an eye out on especially Twitter, which we're still calling it here, or wherever you're subscribing to me on this. This goes out on YouTube and LinkedIn and Twitter and Twitch. So I've been playing around with all of those formats. So yeah, today is the last 2 days, and what we've done every day so far is, let's just bring this up. We have been building a circuit and then partly tearing parts of it down. So bits of this circuit seem to be like the core that stay on a daily basis. So the buzzer has become part of the core, the 3 LEDs that are actually different colors, even though they look clear. If we make this really big, if they look clear, but they're colors when they light up. And the PiHut itself, of course, while we're doing all coding. So what generally changes is what is attached to the mini breadboard or the sort of daughter board, and that changes most days. So if you want to go back and see what we've done in the past, there's a YouTube playlist for that, but also I put a page up on my website. So that's quite a long URL. If you can't remember that, then it's actually in the show notes if you're on YouTube, or just go on my website at simonprickett.dev. You'll find it. It's right there on the front page. So what else has happened? Not a lot has happened since yesterday's stream, because yesterday's stream went out a bit later in the afternoon than I thought. So not really been up to much since then. I do have the new Wales mug that we bought on a trip to Wales. So this is getting its first outing today. And yeah, nice shiny red dragon castles, all that stuff, sheep on there. Yeah, so I've now got Wales, Scotland, England, and a few cities as well. So I think what we need to do at some point is go get a Northern Irish one, if there even is one. I assume there should be one. So we'll see. So maybe visit a Northern Irish Starbucks at some point. Other stuff for today, nothing very exciting. I need to replace a bulb in the car because we went on a long trip with the car to Wales. And it's traditional with the car that when I take it on a long trip, it decides to blow at least one of its bulbs. So this time it's the rear, one of the ones that illuminate the rear registration plate, which is at least an easy one to do. But I've run out of those because it also seems to, those are pretty much consumables with our car. It seems to pop them quite regularly. Had it like 3 years and put maybe 4 in there, and there's a pair of them in the back. So I'll have to pick up a couple of those and maybe do some Christmas shopping ahead of the rush, get some food in or something. But anyways, right. So we were here for, not prattling on about that stuff, we were here for the Maker Advent Calendar. So there's plenty of videos on the channel now. And let's turn off that ticker. I think we've seen enough of that. There's plenty of videos on the channel now that cover what this is. And basically, I've been working from box number 1, the big one at the top here, all the way down. And the thing has been, I've not got any foreknowledge of what's going on here. So I've not looked inside this. The only preparation that I had ahead of time was knowing that I would need Thonny, the sort of basic IDE for MicroPython, and that was about it. So we got caught out a little bit the other day with the temperature sensor where we needed some cold water and I didn't have any, but we kind of changed the code a bit to accommodate a different temperature range. And we used the fact that I was drinking a cold drink at that point and pressed it up against the cold drink can. So, you can improvise. So these things here come with the daily box guide. So this is the choice between the two different advent calendars. The black one focuses more on LEDs. We've got the red one here. Then you go through that and you get this daily guide. And these have been really, really well written. They've been very easy to follow and pretty comprehensive. And then they also have user comments in the bottom. So people have added their own commentary or in some cases additional ideas. So like I was saying yesterday, some more notes for the buzzer so you can make proper piano. Right. So without further ado, we want day 11 today. So we're not going to go down any further on the spoiler alert. At the end of day 10, it said we're not going to be doing any more sensors. We've done a lot of sensors. So we are going to do day 11 here. And OLED, maybe a display. So let's see. Welcome to day 11 of your 12 projects. Today we're playing with a really fun and useful component you'll use again and again, a mini I2C, which is a way of talking to it, OLED display. Whilst only teeny tiny, these little displays are great for showing data from your project, such as sensor readings and scores and so on. Okay. Oh, there it is. Look. So yeah, it's a little display. And even more, I know I say this every time, even more male-to-male jumper wires. We're getting so many of these. So the thing to do then is let's go grab our box here, pull out number 11, which is a green one if we're keeping score, and open it up to see what's in there. So, wow, this display is quite small. I'll hold it up to this camera. You can see it's pretty small there. And we'll put it under the second camera so you can see it and make that a bit bigger, like so. There we go. So that's how big it is, pretty small. So I will just put box 11 back. And I realized this morning, I was like, I'm going to have to put all of these things back in the box. And I've just got a big discard pile to one side of all the stuff that's come off the circuit, been taken away. And I realized that I can just watch the videos back fast and see what components came in which boxes and what wire colors they were and put them all back quite nicely like that. So I am just getting these out and we will see here. This tiny display has got some pins on it and it's very small finger for size. And it's also got a peelable bit of plastic on it. So we'll discard that, put that over there to go in the rubbish, and empty our plastic bag. I've got a huge collection of plastic bags now as well that I will reuse to put these things back into. And we got 4 of these connectors this time. So we got red, white, yellow, black. So I've been using the convention of red is power and black is ground, and then I've been using the other ones for data connections. So let's see what they want us to do with this thing. What are we doing here? And I'm just going to adjust some stuff. There we go. What are we doing here? What are we doing here? Today's project, we're going to display data on our mini display. They're relatively easy to code. Okay. They do require the installation of a library. So that's like external code that we're not writing. So it'll be in another file and we won't write it. So if you're familiar with regular Python, it'd be what you install with pip or poetry or whatever you use to manage that. And we'll see how they want us to do it in MicroPython. So what is an OLED? Organic light emitting diode. You might have seen this in some other things. Like I think there's an OLED Nintendo Switch, but I'm not really sure. I'd have to ask my nieces who are like the Switch experts. You may have seen this mentioned on TVs. It's a type of digital display that uses LEDs and layers of thin organic film between two electrodes. Okay. I2C is inter-integrated circuit. I didn't actually know what that stood for, so that's new to me. It's another type of communication protocol which allows multiple devices to communicate to a controller like our Pico. Okay, so I've used I2C before with some Pimoroni products, but usually through their library code that handles that. So I've not really had any experience with working with the protocol directly. That requires just 2 wires to communicate and 3 and ground. So again, we're going to need power, ground, so red, black, and then a couple of datas. So I guess that's why we have 4 of these. Okay. So first off, we need to construct the circuit. Wow, we're actually going to remove the long-term components on the circuit. So our circuit looks like that at the minute. It's got all of this stuff on it. So today we're finally removing the LEDs, which were like the first thing we ever put on there in, I think, day 2, and the buzzer, which followed pretty soon afterwards. So they're all going because we might be using buttons and sensors. So if you haven't already, remove everything so you're back to a clean breadboard with just your Pico fitted. Okay, so let's just pull away at these and hopefully don't lose anything. So those, I'm going to put the resistors next to the LEDs so we know that those are the LED resistors, and remove the buzzer, and we'll leave the little board in the sort of mess at the moment. Put everything else in the discard pile off camera. And right, so we have got an empty, let's orient it like theirs. Well, that looks like theirs because the camera's the other way around. So we've got that, and we've got these things. I think we're ready to move forwards. Next, fit one of your buttons and the OLED display into the breadboard like we have below. So I need to go find the button in the discard pile, but luckily I can see one. So there's a button. They have 4 legs, if you remember from the previous video, and they have a little cap on them and pressy. Right. You may want to peel off the display's protective film. Already did that. So that's gone. So we need, let me just orient this the right way around for me. We need this on, so there's 1 track down. I don't think that's really going to matter, but let's try and play along. It's quite stiff. Oh, it's gone in. Okay. That went in all of a sudden and kind of surprised me, but there you go. It's in. And then we need a button that is off to the edge, and they've got the legs in the sort of top and bottom orientation. So let's do that. That's not happy. That's kind of got a bit all bent up. So let's try this again. I'm going to have to straighten that one out. Off camera, it looks like we have 3 buttons, so hopefully I don't mess this one up. Let's go easy on it. It's not really a good fit in this orientation. It really wants to fit the other way around. So I'm just going to do it the other way around if it wants to go that way. I might have banged these up whilst removing them before, but okay. I feel that's in. Yeah. So I've got a button there, look. And we've got an OLED display. And we will keep going and see what happens. Next, we add our 3v3 connections. Run a jumper wire. I wonder if the button does need to be the other way around, actually, because of... Go pull that out and try it the other way around. It's great television, isn't it? Hey, it went in the other way around. Okay, I'm happier with that now. So next we try our 3v3 connections. Run a jumper wire to the upper red channel. So I'm not going to pull these jumper wires apart. I'm going to use some that we had before because we've got loads. So here's rub one. So run a jumper wire from 3v3 physical pin 36. That we can see is the 1, 2, 3, 4, fifth one down on the right from the USB. So we've used this pin so many times, I still can't remember where it is. 1, 2, 3, 4, fifth one down there. So I run a pin from there to the upper red channel. So that's over here. I will make this bigger when it's when I'm finished getting my hands in the way. So the upper red channel there. So we've connected the rail on the edge to a 3V 3 pin. Then connect the left button pin to the same red channel and the second OLED pin to the same channel, like this. So they're going to go to the edge of the board. So again, I'm not going to use these new connectors. I've got this big discard pile over here of things from previous days that are just off camera. So here's some more red power. So now we need the anywhere in the red lane or red row to the button on that side. Okay, so we got that. Then anywhere in the red to the second one, which it actually, let's see if we can just make this a bit bigger. It actually says VCC there on the thing, which basically means power. So second one, VCC on the OLED is there, and my power rail is there. Right. So just quickly make this a bit bigger so you can see it. There we go. So we've got power coming from the rail into the OLED and into one side of my button, I hope. My button is kind of falling off because it came loose. That's not good. Okay, I'm just gonna you do need to be careful when removing these components because you might bend the legs. Okay, I'm a little bit happier with that now. So the button is sat flush. Power things are lined up with it. We'll run with that, see how it goes. Right, so back to the instructions. What's happening here? So next is our ground pin. So connect the first OLED pin labeled ground, GND, to the next nearest ground pin on physical pin 18. So we did have the whole rail set up to be ground in a previous circuit. So that whole blue line next to the red one. But they've told us to remove that. So we're now going to connect to a specific grounding pin on the Pico. So I need a black one out of my discarded items pile over here. Ground is, as they say, it's the first or leftmost as I'm looking at it. Yeah, this is tight. It's tight, and also my fingers don't work very well, but we'll get there. I'm going to take the positive one out to make room. Should have probably thought about this, shouldn't we? Right, ground is in. VCC can go back in next to it. Okay, so they're sat there nicely now. And then we need the 1, 2, third pin on this top, and it should be a ground pin. So 1, 2, 3. I'll try and keep the wires so that they don't mess with the display. They don't cover it, because obviously at some point we're going to want to look at the output that's on the display and hopefully wonder at it, or marvel at the wonder of it. Right. So we've got that set up. We've got ground and power. We haven't got any data yet. Now for the 3 GPIO pins, which we'll talk to our Pico. So we need 3 more, not white, not black and red. So we've got a yellow, a white. I don't know if we've got any other colors. Might have to be a second white looking at this. So, okay, I don't have 3 distinct colors like they have in the diagram here, but this will do. So connect the right button leg to GPIO 18. So that's this purple one on the diagram here. So let's do that. I'll use a white. So my right button leg is here somewhere. It's a little bit crowded in here, but it's on. There we go. Steady, steady. Right. The right button leg to GPIO 18, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down that top face of the Pico. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sanity check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we've got one of the data wires connected, that white one there. Now we need the third OLED pin labeled SCL to GPIO 1. So SCL, the third one here, that's the orange connection. So I'm going to use yellow for that, so that we don't have 2 white lines next to each other and kind of confuse where they go. So it's yellow there. That needs to go to wherever this orange one goes into here. So physical pin 2, second one from the right, just off the USB. Okay, USB 1, 2. There. And then the fourth OLED pin, this is the final one, labeled SDA to GPIO 00, so right on the end. We'll do this one the other way around. Plug in this white plug right at the end of the Pico here. Again, that's quite stiff, but we'll get there and then route this around to plug in at the fourth pin there. And okay. Whoa, we need the light sensor and the mini breadboard. But before we go that far, let's just take a look at this a bit bigger. If we turn it around this way, what I've tried to do is make it so that the display and the Pico are reasonably visible. So we've now got wires from a button here, an input to a display. Well, not to a display, but to the Pico, and then the Pico to the display. So we will see how that goes. That's where we're at. And let's get back to it. So we'll be using the light sensor from box 6 in our examples today. Yeah, I think I can see that in the discard pile. So we'll need that, and we'll need the mini breadboard and a 10K resistor. Luckily, the resistors are all colored, so I should be able to recognize it. Right, let's put the main circuit to one side. I've still got this brake beam stuff on the mini breadboard, so I'm just going to really quickly strip the mini breadboard of the brake beam and its sensor wiring and its resistor. Put them, I'm running out of space off camera here, put them over there. Now we've got an empty breadboard. And then we have a light sensor and I think I'll put its resistor next to it. So yeah, I think these are the components we want. Let's try that. The long leg of the light sensor needs to go to the left. So as I'm looking at it, that's the long leg to the left. Okay, so there's the light sensor, and then we need the resistor from that leg to just another rack. So that'll do. So I've got resistor, light sensor. The way that they're looking at it looks more like this. Okay, so what happens now? Now to wire up the light sensor to our Pico. So we need a ground and a data and a 3v3. So again, I'm going to try and stick to my coloring scheme. I'm going to get a black wire out of the discard pile, a red one, and we use a yellow one this time for the data. So we've got roughly the right wiring scheme going on across this whole circuit. Try and keep it tidy. So connect the left resistor leg to the ground on physical pin 28. Okay, so the left. Let's get this back right again. So the left resistor leg, so this track here, that goes to ground physical pin 28 on the Pico. But I'm going to put all of these into the mini breadboard first. The right resistor leg, which is also the the right sensor leg, sorry, goes to 3v3. So that's the red one. And then the data, the left sensor leg, between the leg and the resistor. So any of these here. Okay, so these are the three connections we need to make to our Pico now. So let's see where they go to. So Pico's getting a little busy here, but bring it back. So starting off, the ground connection, our black one goes to physical pin 28, which is 1, 2, 3, 4, 5, 6, 7, 8 down from the debug end of the Pico. So that's this end by the screen. 1, 2, 3, 4, 5, 6, 7, 8. There. And double check. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. The data one, physical pin 31. So that is 1, 2, 3 more on from that. Yeah, 28, 29, 30, 31. Okay. So that's the data one. And that is counting from this edge 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we're going to count carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So data goes there. And then finally, we've got the power on physical pin 36. So we already have a wire on pin 36, but we can have multiple just by plugging them into the same track in the board. So let's squeeze that in there. So what we've got now is, if I turn this around a bit and make it big, is we've got all of those connections made up. So they're going into that bit of the Pico and they're going to here. So hopefully this all works for us when we do whatever's next. Now turn your breadboard to 90 degrees so that OLED is facing you. We'll worry about that when it's doing something. Right, install the code libraries, plug your Pico back in and make sure it's recognized. So in goes the USB that's connected to the computer here. And here we go. We've got a REPL. So remember, we can do Python stuff here and you get Pythonic output. That's all fine. So that is good. That's working. And let's see what they want us to do. So we need a code library package that isn't included by default in MicroPython. Well, why isn't it included? Because there's a lot of options and different things you can do. And if you put everything in the core will get really big. And these devices are quite small. So you want an optimized core and then optional things. And also it allows other people to write library code. So when we import this we will then import this library when we write our code. So we import it similarly to how we use built-in things. So let's see how they want us to install a library. If the steps don't work and you see certificate errors, you may need to install the library manually. So to do this, oh, this is a bit funny. This is like the if it doesn't work process, right? So we're going to do it this way. In Thonny, from the top menu bar, select Tools, Manage Packages. So Tools, Manage Packages. There we are. Okay. Now you need to make some room in. You should see something similar to this. Yeah, I'm running the dog thing, but that's okay. In the search bar, enter MicroPython FSD 1306. So let's make sure we get this right by pasting it. And there's some options. And you should see results like we have below, including the MicroPython SSD 1306 module. So that's the one we want. Select the line that goes to the information screen for that module and then hit the install button. Okay, so there we go. It's MIT license. It's written by somebody called Stefan Lehman, and that's where you find out information about it. So let's install it. So it's installing that. Once this package is installed, it will show on your installed packages list on the left, and it's ready to use. Okay, so they've got some other ones installed. I do not, so I'm going to have just this one. Okay. Right, so I think we've done all the preamble. We're now at activity 1, which usually means some coding. So we'll start by showing a single line of text on the display, and it'll be hello world, of course. Let's just close this dialog. To use this display, we need to import I2C as well as the library we have just installed. So we need the communications method that the screen uses and the library for the screen. You'll see this in the first few lines. Okay. And we have to wait around to let the connection light stabilize. Okay. We define this display size in pixels and the driver chip it uses. We got that many pixels, apparently. Then when we want to display something, we always go through the same process. Clear the display, define the content, push to the display. This is something I'm familiar with working with like Pimoroni e-ink displays. Their library works similarly. I mean, you don't have to clear it. You can additively push more things. But you basically define stuff and then you have to tell the display to update. Just saying print something doesn't print it until you update. So that's pretty familiar. We don't clear the display every time. It will write the new content on top of the old, which is a mess. Not always what you want. Sometimes it is if you like plotting a graph or something, maybe. Just plot the next point. Okay, so we're going to clear the display with display.fill 0. So I guess set all the pixels to off and then display.text, and that's probably a position on the screen, start position, and then push it with display.show. So let's just copy this and paste it in. So as they said, we've got some imports. Let's make the shell area a little bit smaller. Okay, we've got a short sleep to stop I2C falling over. Define the display size, clear it, write a line in text and show it. Okay, let's try it out. First off, it will probably be good to align the display with the camera a bit. I don't know if it's going to, which orientation it's going to, will the text be upside down? Will it work at all? Let's find out. So, hey, it did work. So I'll make this this big. And I can mess around with the zoom on this camera. So let's just see if we can improve things for you there. So, and we can mess around with the focus. Let's try. Yeah, autofocus, not so good. It's over focusing on the LEDs. Let's see if we can bring that into focus a bit. Struggling there. It's very bright. Well, it's very bright. The camera's not that bright. But you can see we've got "Hello World." There's like an outline of the text there. It's way sharper than that in real life. But I'll zoom back out again, and you get the idea. You can sort of see that well enough. The fun with these displays and LEDs and cameras is sometimes they need diffusing to work really, really well with the camera. So, okay, so we've got our basic text display, which looks like this working. What are we doing next? So we know the circuit was wired up correct. Well, I'm not going to say all of it was wired up correctly. We know the bit with the display was wired up correctly. We haven't tested the button yet. So multiple lines of text. Let's go one step further, add more lines and change the position of the text. But first, let's cover those arguments. So you'll notice there's a couple of arguments after the text. The first arguments determine are there X, Y. So how many pixels across the display to start, and then how many down. So 0, 0, top left-hand corner. Yeah, that's consistent with what we're seeing. So yeah. So we've managed to squeeze 3 lines on by setting each one at a different height, which just takes a bit of trial and error. So let's just copy this, paste it into here. And as you can see, they've got multiple lines of text this time, but what differs are the coordinates. So they're going to start up and down the screen and at different places. So this is going to be top left. This is going to be the top a bit further across. This is going to be down and across a bit, I would imagine. So if we run that, then try and get the wiring out of the way and see if we can bring this up. You can see we've got 3 different text lines and they are offset a little bit. So that's working. Let's just, there you go. Very bright. So that is okay. To the naked eye, it's really clear as well. I can read that quite easily, even with my less than fantastic eyesight. Okay, so that worked. Activity 3, the endless counter. Small OLED displays are great for displaying data, and they can refresh quickly enough to show changes at a very fast rate. That's good because the refresh rate on the display, if you're counting things very fast and you're going faster than the refresh rate, like if you're using e-ink or something, it's going to be constantly displaying and get behind, or you're going to have to skip a few interim values and so on. But if you've got something fast that can keep up with you, then this is all good. So what do we got here? Let's see. Let's create an endless sort of counter. No physical inputs, just a counter that increases by 1 every loop. So just code-based counter. It's an integer. And we need to convert the counter to a string because Python has some pretense of being a type language. And we do that with the struct function. So, yeah. Okay, we could use an F string. I demonstrated that in a previous video, but we're not going to worry about it. So let's see what's different here. So now we've got a while loop. We've got a counter. We're going to print the counter. We're going to show the value of the counter with this text, the endless counter. And we're going to sleep for not very long, increment the counter. I guess this isn't really an endless counter because we'll probably get like numeric overflow after our number gets to whatever the biggest integer Python supports is, but we'll not nitpick that too much. So, okay, stop what we were doing before, run this, and yeah, you can see it's updating there in the console. If I make the display big, you can see there's a number that is incrementing there. Again, it's a lot clearer with the naked eye, but Right, we've got a counter. So I'm going to stop this, come back to what do they want us to do next. So we have a counter. Activity 4, the naughty or nice game. Oh, okay, so festive games. So we're now going to create a game that decides your festive fate. Let's make a naughty or nice game. Are we on the good list? So this shows naughty and nice with a marker that quickly switches between the two. It's like one of those prize games where the lights go up and down the pole and then you press the button and it wherever it stops is what you win or nothing. So the aim is to land on nice. So we're adding an input here, and the input's this button that we've got. So I've drunk all my coffee and we're still on day 11. So hopefully we'll be fine for day 12. So we use this variable to switch between two if statements within our while loop. So we want our display to constantly move the marker between naughty and nice. So it's going to have like a chevron that I guess flips between the two. To do that, we have two if statements and a state variable. So similar to what we've done before for counting, remember with the tilt sensor, counting those tilts. If the state is naught, the text is pushed to the display. The text pushed to the display shows the marker on naughty. If it's 1, it's on nice. And then each statement also changes the state. So next time around it alternates. Okay. Then inside that, we check if the button was pressed at that very moment. I wonder if we could just hold the button down. If it is, the code inside it updates the display to confirm which option was selected, followed by a 2-second pause. Right. So let's look. This is all set up. We've got a state variable instead of the counter variable we had in the last one. So we're going to look at the state. We're going to swap the thing over. And we are going to update the display and then so on. Given we've already introduced functions, we could have maybe used a function to handle this and just passed it parameters of is it the naughty state or the nice state, and it would redraw the screen for us. But we're doing it inline, that's fine. But you see, we've got some repetition here of all of that. And if you get it right, oh, hang on. No. So we are handling the button click in both of these states as well. So if you click it, it checks on what the what's it doing there? Oh, it knows. So that's the naughty state. And yeah. And this is the nice state. And then this could probably benefit from some functions to like reduce repetition a bit, but we'll just run with it as is. We're not here to refactor it. Okay, and then once you've had a go at the button, it sleeps for a couple of seconds. So you can't just hold it down and hope that it's the right thing. So let's play this. And hopefully my button works. So it's sort of alternating between naughty and nice. And can we see that better here? So if I move you can see the chevron is moving between the two. And then if I unfortunately put a big finger in the way, see, oh no, I got the naughty state then. Oh no, I got the naughty state again. I'm not good at this, am I? So yes, got the nice state. So that's working nicely. And you can see this screen is pretty fast at updating. So it's flickering away there, and it's basically rewriting the whole screen when it does that. So because we're doing these display, let's bring the code back in. We're doing clear the display and then rewriting everything every time. So that's a pretty fast display. So it's capable of coping with that. And also we know the button that I wired up works now. So the only thing we've not tried in this whole setup is the light sensor. So let's scroll past this code that we just ran. Here we go, the light sensor. Activity 5, that's a lot of activities today for day 11, but I suppose this thing is cumulative. It builds on the skills and the parts that you've already got from previous days. So showing sensor readings on your OLED is quite possibly one of the most useful and fun ways to put it to good use. So we're going to read the light sensor and push it to the display. Okay, so we're going to reuse similar code from the light sensor from the day before. So if you're interested in that, go find day 6's video on the playlist, or go find it on the web page on my website, whichever one you prefer, and check that out. So let's see. The same initial OLED imports and setup code is present, and we've added the light sensor pin setup back in, linking it to GPIO 26 along with the ADC import. That was due to the type of sensor it is. And in a while loop, we take a reading from the sensor, turn it into a percentage, round it off. We've done that sort of stuff before, as they point out. And then we're amalgamating all of these things down to a single line of code. So we're just going to stack some of these function calls by the sounds of it. We then push this data to, or chain them. We then push this data to our display. We use the first line of the display to show some text, and the second line to show the reading. Okay. So again, we have to convert the light to a string because we're using that sort of strings in Python. We're not using F strings. And we also add the percentage symbol to the end. So I'm going to copy the code, but let's quickly look at it in here. So set up the display like before, set up the light pin. Okay, while true, sleep for half a second, get the light sensor and do all the things on it to convert it to a percentage. Put it out on the console and throw it up on the display. Okay, so I think I already hit the copy button. Let's do that. So let's see what they're doing here. So yeah, we're calling light sensor.read U16. That gets the number, divide it by the possible range of values, multiply it by 100 for a percentage, round it to 1 decimal place using the round function there, print that out, convert it to a string here for display, and put the percentage symbol in the end. Okay, so let us run that and see what is happening. So we're getting values, so 18, 17, 18, what have you, and those are appearing on the screen, a little bit blurry. So what I did before was, I'm just going to grab my phone. What I did before with the light sensor was we can flood it with some light using the torch on the phone. So if I do that, you'll see it's shot up to somewhere in the 90s. It's a little bit blurry to read on the camera there, but there you go. We're at 96, 97, 97. Turn it off again. Drops right back down to 15, 17. And then if I cover it with my fingers, 4, 5, let go again, 11, 13, 15. So the light sensor is working, and it's definitely outputting values to the screen that we've got. So, that's day 11 completed. Okay, so we use the OLED display. If you want something that shows the results of your sensor project locally, or some sort of status or whatever, this is pretty good for that. It was reasonably easy to wire up, and the library makes it pretty simple. So let's recap. On day 11, we learned how to wire an OLED to the Pico, introduced the I2C comms protocol, learned how to install packages in Thonny, learned how to code. We did quite a lot, really. Text, positions. And then we reused state variables, and I reused wires because I didn't want to. I've still got the ones from day 11's box. They're still nicely glued together, so they can go back in day 11's box for whoever does this next time around. So we're nearly at the end of our 12 days. You can remove the circuit from today. I'm going to leave it because I don't really know if they mean all of it or what. So we'll see what tomorrow is before we do that. See you tomorrow. So tomorrow is today. We're going to do day 12 on stream now. But because I ran out of drink, we are going to... I keep tripping the menu at the top here because I've got this zoomed so that you can see it. We are going to very quickly just take a second. So I'm going to just run out, grab a cold drink, and come right back. I'll be like 30 seconds. All right, so see you in a minute. And we're back. Okay, so I'm just gonna do this second. We are back for day 12, and I've got a fresh drink, which means my voice is likely to last. So I'll just get the noise of opening that out of the way. Right, lubricate the voice. We are good to go. So day 12. This is the last one. It's also in common with day 1. Day 1 up the top, day 12 down the bottom. It's a bigger box. So let's see what it says for day 12. I have no idea what is in here. So, RGB LED strips, so programmable lights. Today we're playing with an RGB LED strip, but they're addressable LEDs. So we can basically control each one individually. These are really fun products. I have got off camera some of the Pimoroni unicorn products. This is a big one. So each of those are LEDs that you can control individually. There's Pico on the back, and I've got those in a couple of different shapes, and you can expect to see some stuff with those on this channel at some point soon, because I've already been working on things with them. I've just not got anything to a state where I've shared it much yet. So, right, back to this. These are addressable LEDs. Time for some ultra festive blinky. So if you're doing the black box, one of these, I think that focuses on this sort of thing more. But I don't know. I've not seen. I need to look on YouTube if anybody else is doing the other one. I know there's at least one other person and their daughter doing this one. And at some point, I'll link to their channel from my page. But they're a little bit ahead of me. They've already finished. I've been trying to watch their videos after I've done the same day. So I'm trying to maintain that wall of no knowledge of what's coming up. Anyway, so warning, some of today's activities contain flashing lights, which may not be suitable for those with photosensitive epilepsy. This is true. If we're going to flash things and you have epilepsy, you might want to skip through that or look away. So this is a thing. I have a relative who has that, so you do have to be careful. Right, so in this box, the big box, let's get the big box out of the calendar. It's a nice big red box. This is the last time we're going to be doing this. Well, never say never. It's the last time I'm going to be doing this until we do the other one next time, or they come out with a different one, or someone else does something like this. So this is the last time for this sequence, but never say never. So one custom addressable LED strip with male jumper wires. I'm going to put the it's quite big. It's in an electrostatic bag as well. Today's a big one. It is physically big, and I guess we're going to do some interesting big things. So can I open the bag? Don't use teeth at home, but I haven't got scissors within reach. So yes, I can. So let's just look at that on the second camera a minute. See what we've got. There we go. Make it nice and big so we can see it. So we've got this LED matrix. Oh, sorry, it's not a matrix, strip. And as you can see, individual LEDs there. And these are usually, I'm not going to attempt this because it's got connectors on it. But you can buy these in a roll and then kind of cut them to length and put your own end connectors on. This one has got the connector there. I think that might be for, oh, it's just a blanking one. So that's the end of the strip. And then we've got our familiar male header pins here for the power, data, and ground. Yeah, so 3 things. So that's quite a nice bit of kit to find in a box on the Advent calendar. Question is, what are we going to do with it other than obviously something with flashy lights? So I'm going to put the static bag away and put the box away. And I really do like that they took the effort to make this 12 boxes in the boxes, and it's all branded and all of that. It really makes it quite a nice thing, rather than, you know, it could just be in bags with numbers on that are thrown in a box on their own or something. But I like that it's boxes within boxes, and it's got that proper Advent calendar thing to it. Right. I suppose one thing you could do is just repurpose the box into like a 12 Advent calendar thing and put other things in there like chocolates or something. But anyway, we're going to do this. So we're going to learn how to light up the lights in the strip individually, how to code different colors, how to create a light chaser, and then a light chaser speed controller using the potentiometer. Woo. That's deep in the discard pile somewhere, so we'll have to dig that out. So what are addressable LEDs? WS2812s, which are quite common. Adafruit, yeah, call them NeoPixels. The Pimoroni products, so here's a small one, the Unicorn range of products, use them. So that includes that was a Stellar Unicorn, that's a Pi Pico thing, but also like the Unicorn hats for the regular Raspberry Pi. I have done projects with those in the past. You'll find them all on the website, which is over there. But we're here to do this one today, so we won't talk about that. If you're interested in like other sorts of, especially the Unicorn hat, I've done a thing with probabilistic data structures and Python in that, which is kind of fun. Great. So what are we doing here? They contain 3 small LEDs, a red, green, and a blue, and then you can mix them by, I guess, turning them on at different intensities or what have you to get all the different colors. So it's a bit like RGB. If you do like HTML websites or paint anything digitally, create images, RGB color codes, you know, the red, green, and blue components of each color. So each of these has a tiny controller chip that allows us to talk to them individually. So rather than, yeah, these aren't just like in series and they all get set to the same color. We can control them individually, and then they always need a microcontroller, so that's the Pico in our case, to tell them what to do. So with much longer strips, you would usually have to worry about external power. We don't for this because it's short enough. Yeah, if it was really long, you'd want to power these off something that wasn't the microcontroller and just use the microcontroller for data. If you're interested in this, we'll sort of flip over really quickly to over here. There are, let's see if we can find it. Pimmer only do these plasma kits, and they actually have a Pico here with the stuff that you need to power more LEDs. You see, this is like a 5-volt power and all of that. So you can either buy a kit from them with, they provide different containers, or you can do the bring your own bottle one. And I think you can also just choose your own LEDs. But basically, they do this thing called the plasma stick that makes working with these really, really easy at greater scale. This is also a Wi-Fi Pico, so you can connect to something. And one of the fun things you can connect these things to is something called, I think it's the .com. Yeah, there we go, to Cheer Lights. So Cheer Lights is a really simple IoT project idea. If you've got some of these LEDs, you can set them to a different color. And what happens is when you tell the Cheer Lights bot, usually on Discord these days, I don't think it's on Twitter anymore, to change the Cheer Lights to, say, purple, then everybody that is on this, everybody's project that is connected to Cheer Lights server globally will change to purple, so you can control lighting all over the world and contribute to it yourself. I did a project with that. Again, project for that is on my website, so go find that if you're interested. But we digress, and that was a digression from a digression. So the point we were making here is we don't have to worry about the power given the size of the strip that we have got. So we'll be powering this from a pin on the Pico that gives us the full 5 volts rather than 3 we've used for everything so far. Okay, so this one is already built up for us. We don't have to do any preamble of assembling it. So construct the circuit. So we're starting with a mostly bare breadboard. So let's, okay, they really do want us to clear it down. So we've got all of this from yesterday. So first job is pull the power. And then I'm going to disconnect the secondary board there. And pull all of these wires, and that button just flew off kind of pretty much on its own. It was not very well connected. And now I've just got the Pico and the OLED. Let's see if we can gently get the OLED off without bending its legs. Yeah, it came out nicely. So put that in the careful discard pile. And now we've got just a Pico. Yeah. So what happens now? Next, grab your LED strip and fit the wires as follows. Unfold it so we can get to these wires. Okay, there's some degree of separation in the ends here, but then they're glued. We can always pull them apart if we need to. So place the red wire in the V-bus pin, physical pin 40. That's the one at the very end with the USB to the right, physical pin 40. So that's there. That's going to give it 5 volts. And then black goes into ground, physical pin 28. So that is miss one. And then I'm going to have to separate these out a little bit because they're not going to fit otherwise. All right, so black goes into ground, physical pin 28. Then in my case, green is data, goes to GPIO 28, which is physical pin 34. So that is starting from the end 1, 2, 3, 4, 5, 6, 7 down. 1, 2, 3, 4, 5, 6, 7 down. Yeah. 1, 2, 3, 4, 5, 6, 7 down. Okay, so we've got 3 wires connected to the Pico like that. I will just make that a little bit, excuse me, larger and easier to see. So there we are. So that's our wiring, and then obviously off camera is the LED strip like that. Back to the instructions. So hit the green wire. Yep, done that. Okay. Next, we add one of our buttons and the potentiometer. Fit them to the left of the pico as shown below. Okay. Remember that your potentiometer looks a bit different. Right. So hopefully I can get this button back in again, because we were having a bit of fun with that. So the button goes. It can go. Oops. I'm going to take this away so I can work with this. So the button goes into there. Okay, so the button's in reasonably well. Now I've got to actually find the potentiometer, but that's easy actually. It's this big thing. So okay, the potentiometer has a gap between each of the legs on like a diagram. Yep. So potentiometer can go in like here. There's just enough room. So there we go. We've got a button and a potentiometer. See what happens now. Let's wire the button. Our button needs the usual 3v3, not the 5. So yeah, we want to put the right amount of volts through the button. Connect the left leg of the button to the upper red channel. So again, we got lots of discarded wiring here, so we use the right color. So left leg of the button, that's this one, to upper right channel. That's going to be positive, I guess, like that. Then connect the right leg of the button to GPIO 15. So we want a data colored thing. So I'll use a white one. Right leg there to GPIO 15, which is physical pin 20. So that's on the debug end. It's the very end one. So it's easy to find. Don't do any counting for once. Right. And then we need to wire up this top rail here to be powered by the Pi's 3v3. So need another red. Comes out of the top into physical pin 36, which is 1, 2, 3, 4, 5 down. So 1, 2, 3, 4, 5 down. So that will supply power. Let's see. That this cable here is essentially jumping power across to the rail, and then it's making it all the way across the board to the button. Let's make the circuit large so we can see some of that. So yep, button 3v3 power is jumping across to the rail, and then from the rail it comes back into a button. So we haven't got any wires for the potentiometer yet, so I'm guessing that will be probably our next step. Yep, connect the potentiometer with 3 wires. So we need ground, 3v3, and GPIO. So again, I want a red, a black, and let's use yellow this time so we can tell the button data separately from the potentiometer data. Okay, so connect the left leg to the ground pin on physical 18. So potentiometer need to line up where left leg is. It's a little bit difficult to see because the barrel of the potentiometer is in the way, but I got it. Left leg, physical pin 18, which is the third one in from the debug end, so quite close to our button data pin that we're using this time. So 1, 2, 3. You go there. Okay, so that's ground. That black wire here. Then the middle leg. So let's get the middle leg. That's coming down to the other side of the pi, so that's useful to know. To GPIO 26, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th one from the debug header. So my yellow cable here needs to go count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 into there. Okay, so that yellow one here, I'll make this bigger when we're done. And then the right leg to the upper channel, because the whole of the upper channel is 3v3 power. So finally, we need the right leg to power this potentiometer to anywhere on the upper channel, because the whole of it is 3v3. And this wire is really stiff. Are you going to go in? Yep, it's gone in that one. Okay, like that. All right, so let's just quickly review. So we've got, coming out the back of that potentiometer, we've got 1, 2, 3 wires. One of them looks a little bit like it's at a funny angle. That's the ground one, and then the middle we've got the data one, and then the right we've got this power line here. So 3v3, all of that looks good. So what are we going to do with it is the question. We built it. What are we doing with it? So minimal starter program, 1 LED. Plug your Pico back into the USB ports, and we'll get this thing fired up. So I'll pull that LED strip out of the way. I'm going to turn the whole circuit around so that the power can go and the data can go into the Pico. There it is. Right, that's connected to the computer now. Nothing's happened on the LED strip so far. So we're going to go through some easy examples to see how the code works. So we're just going to light the first LED in red and see how that works. Okay, so RGB, like I was saying before, red, green, blue. It's color system for displaying things on the display. So you might have used it to draw if you're making JPEGs or PNGs or GIFs or whatever. You might have used it in CSS if you are doing web pages, and you might have used the color picker tool in different things to figure out what an RGB value is for a given pixel, an image. So yeah, each of the red, green, and blue components vary from 0 to 255, so they have a different intensity, and that means there are quite a lot of color combinations. We won't even try and parse out what that number means. So inside here, inside each LED, we have 3 actual little LEDs, a red, a green, and a blue. So we're going to turn them on with different intensities, and they mix together to show different colors. Okay. So here's an RGB table, so we can figure out what the color codes are. We'll just okay that. Okay, so we can like mess around with this and so on. So we're going to use red. So it's basically red, green, blue. So red, full intensity, green and blue off, essentially. And we're going to import NeoPixel, which is the name of the library. That's included in MicroPython, so we don't have to go through that library process we did with the OLED on day 11. So, yeah. And we use strip.write to send data to the strip, a bit like how the display worked. Yeah. And then we use 0. So that's kind of like, I guess, an array of LEDs, and we set it to the 0th or first one, set it to a value. So that LED is telling us to drive first LED. Numbers in the brackets for RGB values. Yeah, so that's like a Python tuple, tuple maybe. I don't know, is that only two things? I'm not great with Python. Anyway, so we can do that and we can mess around with the colors. So let's look at the code. So we're going to have this new import, the NeoPixel library. We are defining the strip. That's the pin number and that's how many LEDs is on it. And then select the first pixel and set it to red and just write it out to the strip. So I'm going to copy that, paste it in here, and I assume the first pixel is going to be the one that is closest to the wiring. So like here. So let's see what happens when we run this. Hopefully, good things. Yep. As you can see, we've got that red LED there. I can make this larger. So we've got a red LED there and we've got nothing else. So if I change the values in there, so say I move the 255 to the second parameter and make it, that's RG. So there you go, we've got green now. Then if I turn on both the red and the green, we've got something that approximates to yellow. And if we do 0, 0, 255 and run it, we've got blue. And then we can obviously do colors in between. So let's bring the desktop back. So that works. And as you can see, I changed that to 00255 and just reran it. And we got blue. So what do you want us to do next? Oops, that's the header for the website. So activity 2, using multiple LEDs. So we've got 15 of these. We're only using the first one right now. So we'll first show you a basic method of doing this, then a more efficient method, and then a much better method. So we're going to build up some complexity by the looks of it. So we've only told MicroPython to work with LED 0, the first one in the strip, so the closest one to the wires, the board. And we could just add more lines. So yeah, we could do, here's the first 5, we could set them all to red. So let's do that. This is the opposite of don't repeat yourself, it's do repeat yourself. So when I run that, you'll see I've got 5, and then the 6th one there is dark. So that works, but you know, we're starting to have a lot of code. If we had lots and lots of these, or we wanted to do anything complicated. So let's look at a better method. Let's save the number of lines we're using whilst making things a bit clearer. The only thing our code is changing is the pin number for each of the LEDs. So we can use a for loop and a range. Okay, yes, we could have the pin number as the iterating thing. So we've got 15. So if we do for I in range 15, that will do what we want. Yeah, and then use strip I instead of a hard-coded number so that I gets updated every time through the loop. This isn't the best way, but we'll discover what that is later. So we're going to go for yellow this time, apparently. So 255, 255, R and G, red plus green is yellow. We've got a range of 15. And see how that goes. So when we run that, whoa, it's quite a greeny yellow. Let's see if I can make it a bit bigger. And move things around, but they're basically all on. Everything to the end of the strip here is blasting away and very, very bright. So we have got those up and running. So let's go back to the desktop. See what we do now. So an even better method. I want to simply fill the entire strip. So there's something in the library that does that for us. And I guess it handles something like that loop because it knows how many LEDs there are, because when we did the setup, we told it there were 15. So setup.fill, and then it takes the tuple or whatever that is in Python of R, G, and B values for what you want to fill them with. So if you want to fill them with all the same, that looks good. So turquoise apparently now, so 72, 209, 204. We're getting fancy and changing up our intensities here. So let's do that. Strip.fill, run it, and yeah, we've got something that's a sort of greeny blue, and it's on all of them. So Again, let's just briefly bring that up. There we go. We've got LEDs. They are looking good. And we've got a lot less code. But they all have to be the same color with this. So that's a limitation. But quite often that's what you want. Like if you're doing cheer lights, the thing that I mentioned earlier, cheer lights are always set to one specific color at a moment in time. So all of your lights will be on, unless you're doing something like people build cheer lights history projects where, over time you fill out the strip with the last 15 colors that people set to. You could do that if you want. Right. Anyway, digressions. Activity 3, better color management. Okay, so we know how to create RGBs and like multiple lights. So how do we do different things? So create color variables with the color names. So we can map a name to an RGB values like red, turquoise, yellow, whatever. So the code's a bit more meaningful. So we've used variables a lot. Yeah, we're not going to reintroduce what those mean. So we could do something like strip I equals red. Give the code below a try. So let's see what they're doing. So they've got red, green, yellow, blue. That's interesting. It must be a Python thing. See, I'd have expected there to have been brackets around these, but I guess not. They go in brackets there. Okay. Well, not sure why that is, but that's me. And if this was me doing this, I think I'd give all of these variables uppercase names because I'm not sure whether Python even has the concept of a constant, but you're not going to change these. And I tend to use things that are in uppercase as constant values that can't be changed. So I would use uppercase, but that's just me being a bit nitpicky and maybe not the most Pythonic person. I don't know what Python's convention for this is. So we've got some different colors here, and we're going to set everything to just one of them at the minute. So just pink. So let's run that, and then yeah, there we go. That's quite a nice color. That works quite well on the camera as well. There we go. Carlos. So hi, Carlos. I met Carlos at a meetup in Oxford, I believe. So Python doesn't support constant, which seems weird, but MicroPython does. So we can declare things that can't be changed. I guess in MicroPython as well, that helps with the efficiency on the little controllers, because if you know something can't be changed, you might allocate memory for it differently or somewhere else. Who knows? That's way beyond the scope of this. We're into C stuff there, but thanks, Carlos. Right. So back to what we're doing. So we got pink. We could pick any one of these. So let's pick blue and put blue in here. And when we run this again, you'll see it's gone blue. So yay. That's all good. So we've got something slightly better now, but everything's still the same color. So hopefully we get to do something more interesting. So now we have our color variables set up. We can create a list, which is another Python data structure of these colors. So we could work through colors in the code. So I guess we would set like red, blue, green, yellow, and then we could set them all the LEDs to be red for a few seconds, and then blue, green, yellow. Another handy tool for your MicroPython toolbox. They're essentially a variable with multiple items inside, and you can iterate over them, and you can do things that are called slices in Python as well, which is like take a section of the list and start at like the fourth one, take every second one or something. All right, so 4 strings inside square brackets separated by commas. So these are like the reindeer names, right? So we're going to copy that, and we'll just put it down here in the REPL. So what you get back is those names, and it's sort of like an array if you're working in other programming languages, but this is Python. It's a list. So we've created a list of color variables called colors. We've played out our LED code in an endless while loop. So it's going to go around the list and change the colors, isn't it? Yeah. So for every color in the colors list, run my code block. And then we're going to do that infinitely. And okay, so we've changed when we write to the thing. So we'll look at that as well. We'll pay attention to that. Let's just do this in Thonny for a change. So what do we got here? We've got the NeoPixel library. Again, the strip has got 15 LEDs. It's on pin 28. We've got some color variables, red, green, and blue. Let's just tidy that up. We don't need it, but I like tidy. And then we've got colors list. So red, green, blue. And then we're going to forever iterate over the colors. So for J, that's our iterating variable in colors. Then we're going to iterate over the LEDs. Then we're going to set each LED to red, sleep a bit to red. Do they mean red or do they mean the current color? I think they mean the current color because J there is colors. Colors are red, green, or blue. We're iterating over J. So I think it really does that, the color represented by J. So, and then it goes to sleep and then sends it to the strip. Well, let's see what happens. Ah, yeah. So it's going round and round and round and round the strip. So let's make that big. And let's try and so what you can see is the color in the list is being written out for each LED in the strip with a little bit of a delay. And then because we don't change anything else, the LEDs have their previous color and it's sort of chasing itself round and round and round the strip. So we've got a sort of ring effect going on. That's pretty neat. That's quite a nice effect from pretty minimal amount of code, isn't it? So, okay. So there we go. We've got that. Now, speed controlled light chaser. This is probably where we find out if the potentiometer is working correctly because we put that back into the circuit, haven't tested it yet. So who knows? So we'll use that to drive a variable for the time delay. So we use the potentiometer as like a how fast does this chase around the loop, I guess. So we need to bring ADC back in for the potentiometer. Again, previous video covers what the detail is for that. And we're going to read the potentiometer and then divide that number to make it more useful as a time delay. So remove the raw potentiometer range of values. I think it was 0 to 655 or nearly 0 to 65536 or something. So get that down into a smaller number that makes sense as a sleep. Oh, there we go. Like if we were delaying 65,535 seconds, this would be a very long live stream while we waited for that to happen. So we need to divide down to speed things up a bit. All right, so I'm going to copy this into Thonny and then we'll have a quick look at what they're doing. So preamble the same, set up the strip. This time what's new is the potentiometer. There was a video on day 6 for the potentiometer and I redid it in day 7 because I miswired it and somebody very helpfully pointed that out for me, which saved a lot of debugging time. So watch day 6 and day 7 if you're interested in the more detail on the potentiometer. So then we've got the same color variables, the same chaser sort of code. So what's different is in here, instead of a fixed sleep that we had before, that was like a 0.1 second, which is what you see running around on the camera below me. Now we're reading the potentiometer, dividing it by 50,000 and waiting that long. So we should be able to twiddle the potentiometer and change the speed of the chase around the ring. Let's run that and you can instantly see it's gone very fast. Let's make it bigger. There it is. So what I can do now is turn this potentiometer all the way the other way. And now it's gone really, really slow. You can see it crawling around. It's just doing the red color. And then I can put that somewhere else. It's going a little bit faster. Turn it way up. And we're about back to where we were to start with that fixed delay. And then let's crank it all the way up to maximum. And I guess this is why this came with an epilepsy warning. you've got something that's going around so fast now that you can't necessarily see all of the different colors distinctly. So let's slow it down a bit. That seems like quite a nice speed, doesn't it? Yeah, I like that. So that's going around. We just basically built. We've sort of ended this with a nice Christmas decoration. I think. I'm assuming this is where it ends, or is there more? Thing is, I don't know. No, there's more. Look, button control. Oh yeah, we put a button in the circuit. It seems like a long time ago we built this circuit because I've got excited about LEDs. But there was a button in here, so we're going to hop back to using strip fill to completely fill our LED strip with a single color. However, we're going to use our button to change the color. So rather than a for loop, we're going to use the button. It would be helpful if you could see this. So that's what we're going to do. We're going to use the button as a sort of manual for loop iterator. Instead of entering the color directly into the code using something like strip.fill red or using a for loop, we're going to use another method which uses the index of each color. But what is an index? So everything in a list is given an index. So the first thing is 0. This is like, remember the first thing we did with the LEDs? We addressed strip brackets 0. So that was the first, or 0. We normally count things from 0. LED in the list. So if we've got red, green, blue, red is going to be 0, green is going to be 1, blue is going to be 2. And we can use this to pick from a specific color. So I'm guessing we're probably going to press the button and increment a number between 0, 1, and 2, and then back to 0 again, and use that as an index into our list. But let's see. Yeah, we are. Look, the code needs to know the length of the index, how many things we have, and Python has a function for that. That's called len. So if we do this and get us a REPL here, so that's stopped the code running. So the LEDs below me have stopped doing their thing. But if we do this and we define, oops, that's because these haven't been defined. So we'll just do string for the purposes of demonstrating the concept. So colors, 3 things. If we do colors 1, that's green because it's the 1th thing in the list and we started counting at 0. So 0, 1, 2. And then if we ask Python, how long is the colors list? It's got 3 things in. But if we tried this, that's an error because the 3rd thing has index 2 because we started counting at 2. So 0. So there you go. 0. Right. So roughly that's list index. Back to what we've got to do here. So that was what len does as well. And yeah, they've basically just defined these things and I just swapped them to strings. So we didn't have to define them. We just used something different in the list, but the principle's the same. So everything should come together and make sense. So we've got an index length, how many items are in the color list. And we have to -1 because, like I was saying, there are 3 things in the list. So length will be 3, but the highest index is 2 because we started at 0. That's quite a common thing in computer science. Count from 0. So yeah, we have a while loop that does nothing until the button is pressed, and then it uses an if statement to check how far through the list we currently are. And it will add 1 if we haven't gone off the end, and if we've gone off the end, it goes back to 0. So it's gonna, this is like using the button as a manual for loop. So, okay. And then we're gonna fill the strip with that color. So copy this. Yeah, paste that. Let's have a quick look. So run forever, bit of a sleep because otherwise we'll just be running all the time. It's a tight loop and there's nothing else going on in this microprocessor. If the button was pressed, then we work out how far through the list we were. If we're not at the end yet, we add 1 to it. And if we were at the end, we go back to the start. Then we fill the strip with that color and write data to it. So that's pretty simple. So let's press this and see what happens. I've still got the previous state of the strip from when we ran the previous code. So we've got red and blue. But let us make this large again, and I'll press the button. There you go. So every time I press the button, it changes color. And if I don't do anything, nothing happens. So we replace that for loop with a timer with an input on the button. There we go. And there's a bit of a sleep in there. Okay. So that's working. Good to know. To still wire a button up and not break it. And we wired it to the right power because remember, we've got 3v3 power for the button and the LEDs are using 5-volt power and it's all coming off the Pico. So we had to get the power right. Oops. Looks like we did. Ooh, activity 7. There's more. This is quite a long day. Let's try fading our LED strip in and out. So rather than have everything at the same brightness, write some simple for loop code and another way to use range. Okay. We have a while loop with 2 for loops in it, both using the range. So we're going to use iterate the R value there. Okay. And we are going to use a range between 0 and 255 and an increment of 1. So we're going to count through all of the R, G, or B values. Remember, those the valid values for those are 0 to 255. 0 being nothing, 255 being maximum. So what does this do? It changes the red value by 1 every iteration. So it will fade red from dim to bright. And then we can go backwards. So the step is -1. So before the iterator was +1, -1, we'll do it the other way around. And try the code. Excuse me. Try the code below. So we're going to copy this and paste it and see what's what. So we've got our run forever. We've got a range. So we're going to first go from 1 to 255. So we're going to brighten the light up. And then we're going to take it back down again with the -1 iterator. Okay. Let's run that. And you can see it's, yeah, you'll see those sort of pulsing now. But there you go. As they get brighter, there's more of a sort of halo effect going on with the camera. But that is definitely working. So we've got our LEDs going nicely there. So what we could do is also let's put I in like here and I in like here and use the green component. See what happens there. So they sort of pulse yellowish now. I think I prefer the red actually, but let's do put it back. There you go. That's pretty good. So we've got a nice effect going on there. And oh, that's it. So day 12 is complete. And that means the whole project is complete. So this was a little longer than some of our days, as LED strips are fun and versatile to play with. So yeah, we could do all sorts with this. We could use the button to make, remember we did the naughty or nice thing with the OLED on day 11. We could use this to be like, you have to press when the LED chaser is on a specific LED in the matrix. And that's like some of those games you see if you've been to the US and you see Chuck E. Cheese, they usually have a big tower of lights and you press the button. And if it's in the marked position that is like the win position, the thing spits hundreds of tickets out and you can go get something from the little shop. So you could build one of those with this strip, I suppose, and the circuit we've got. So yeah, we're pretty sure most of you will be turning your strip into a fancy monitor backlight. You could do cheer lights with this, like I said before. Andy Stanford Clark, who sent me one of these motor plugs to play with for a future stream. He's into carbon intensity of electricity generation, which is something else I've looked at on my website. And he's got a strip of these across the top of his monitor that updates showing how much of your electricity is actually coming from wind or coal or gas or whatever. So how green is your electricity at a given time? There's all sorts you can do with these. So yeah, we've learned a few things there. And then sad times. This is the end of the Maker Advent Calendar. Um, if it was going to last 25 days, then it would probably not be as affordable. So this was £40 and it was 12 projects. I think this was pretty good value for money, and that having these instructions be so good is really, really helpful. And also having the packaging be really cool makes it. So I think this is a really worthwhile thing to give somebody or just buy for yourself and do. And then you've got all of this stuff left over to work with. So I've got we'll just turn from the thing to the discard pile over here of quite a lot of stuff. I'm going to sort that out over time and put it back in the box, and then we'll see what happens with the box next. But all of this stuff, because it was breadboarded and we didn't solder any of it, is totally reusable because it's just all jumper wires and things. So yeah, that's all. So we did the thing. We completed it. I am gonna turn the desktop off there. So yeah, we did the thing, and it was a lot of fun. So if you're watching this, thanks for putting up with all of these videos. This was mostly an attempt to get used to live streaming again after a bit of a break, and also to sort of mess around with my home setup and make sure it's all working out. So I am going to be not doing this for a couple of days because we have this Christmas thing coming up. But between Christmas and New Year, I'm sure I'll find something to come on here and demonstrate or talk about. There's lots of stuff behind me there. There's the big plus sign that is controllable. That's got a Raspberry Pi in it. There's only 3 of them up there at the minute, but there's 10 Raspberry Pi 4s knocking around to do things with. And I've got a whole bunch of sensors and things. So if you want to find out what's going on when, the best thing to do is go with the Twitter follow, because all sorts of stuff ends up on there, like GitHub projects and updates to my website, as well as videos. Or wherever you're watching this right now, it goes out to 4 places. Do whatever that platform's subscribe thing is. If you just want to see projects, try my GitHub. That's got most things that I do in it. There is no project for this Advent Calendar series because we used PiHut's example code and it's all out there on the internet. If you want to read about things, go to the website. I generally add articles on the website roughly a little while after I complete projects because they take a while to write up. The latest thing I did was build that little space shuttle, so that's on there. That was kind of a fun Lego thing, but I'll try and keep the pace up on that. And I have a backlog of it on the website is itself a project on my GitHub, and there's a backlog in there for things that I need to do. Lastly, I don't like showing this one, but hey, this stuff costs money. So if you want to buy me a coffee, then I probably won't buy an actual coffee with it. I'll probably buy more sensors or Picos or LED strips or stuff like this that is just a bit of fun. So, and any of that we'll probably make a video about. And if you want to buy the Advent Calendar, it might be too close to Christmas to get one now, but they are still in at the PiHut, so you can find them at the PiHut. This was not sponsored by them. I bought it with my own money. So do I think it's a good thing that you should spend £40 on if you've got that? Yeah, it's a good thing and it was well worth it. I had a lot of fun with it. Okay, so it's Friday. I'm going to go and do exciting things like I heard them emptying the bin, so I better get the bin in off the street and buy some food so that we can eat things over the festive period. But anyway, I will leave you to the rest of your Friday and your weekend, wherever you are. Some of you probably already started the weekend. Some of you are probably in the early morning. And here in the UK, it's about lunchtime. So take care and see you next time. Bye.